Hi, welcome to the Applied Data Science course for beginners. This is the syllabus of the course. In this tutorial, we will focus on theoretical part of one of the popular machine learning algorithm, k-nearest neighbor. In this tutorial, you will learn what is k-nearest neighbor. We will compare its structure to other typical machine learning algorithms. Also, I will show you step-by-step tutorial how algorithm works and highlight some of the important distance matrices. In the end, I will show you textual and visual examples in order to understand the algorithm better. Let's get started. K-nearest neighbor is a supervised learning method, which means that it requires labeled data, developed by Evelyn Fix and Joseph Hodges in 1951, and later expanded by Thomas Cover. So, this is an old algorithm. It's defined by two main properties. First, lazy learning, which means that it does not have a typical machine learning training, but it uses all the data for training while it classifies. Second, it has a non-parametric learning, which means that it does not assume anything about the underlying data. It does not have any trainable model parameters. Let's compare k-nearest neighbor's workflow with other typical machine learning algorithms. In the beginning, we have training dataset. Typical machine learning algorithms have a learning phase, which tries to find the parameters of a function which minimize a loss function. Whereas k-nearest neighbor does not have any learning phase, the input directly is fed to the model part, and main idea is to find most frequent classes of neighbor points, which will be an output. I will show you the illustration example how it's done. But before, let's discuss step-by-step tutorial how algorithm works. First step is to get the training data, which is logical because without the data, it's impossible to create any machine learning model. Second step is to choose the value of k, which should be an integer. The value of k will have an impact on prediction result. And final step is to find closest points, most frequent item class for every new data points. How do we do that? We calculate the distance between new data points and all the training data points. We choose top k points with the shortest distances. These data points are called neighbor data points. And our prediction class of a new data point will be the most frequent class from neighbor points. But how can we measure the distance between two data points? Let's discuss what are the distance matrices. We have different matrices. The most popular distance matrix is Minkowski distance matrix, which has the following formula. Where x and y are two data points in n space and p-value usually equals to 2. When p-value equals to 2, the formula is the same as Euclidean distance. Here is the simplified formula of that one. Euclidean distance formula is the root square from the summation of x and y value subtraction squares. Let's have an example to understand it better. Imagine we have one data point x with the following values 1, 2 and 3. And we have another data point y with the values 2, 4 and 1. To calculate Euclidean distance, we can just use the above mentioned formula and insert our values. 2 minus 1 squared plus 4 minus 2 squared plus 1 minus 3 squared and the root square from this one. As you can see, it results to 3. So the distance between this x and these y points are 3. This is how we calculate distance between two data points. As we understood the distance matrices, let's do step-by-step example of k-nearest neighbor. Imagine we have a wine quality information. Training dataset has 3 features. First 2 features, alcohol and density, are input features, and the last feature, quality, is the output feature. Here 1 represents a wine, with a good quality and 0 represents a wine with a bad quality. We have a test set here, in which we have information about the alcohol concentration and density. Our goal is to find out what is the quality of this type of wine. To do that, we can use k nearest neighbor. Next step is to choose the value of k. Let's say it equals to 3. As we know the value of the k, we need to calculate the distance between the test data point to all the training points using Euclidean distance matrix. Distance between the test point and the first training example is 7.7. Distance between test point and the second training point is 4.47, and etc. Because the k equals to 3, we need to choose top 3 shortest distances between this test point and training points. Top 3 shortest distances are D2, D1, and D3. Their classes are 1, 0, and 1. 1, 0, and 1. Because neighbor points most frequent class is 1, our prediction will be 1 as well. So this wine is a good quality wine based on these training data points. That's it. We have solved the problem. Now I will show you the same example visually. We have the exact same dataset with scatter dot visualization. Here, red cross represents test data point. Orange dots represent wines with good quality, whereas blue dots represent wines with bad quality. Our goal is to find out what is the class of this test data. Is it 1 or 0? To do that, we choose the value of k. In this case, let's say it equals to 3. What is the next step? Next step is to calculate the distance between this test point to all the other points. It's easy to understand even visually that top 3 closest points are this one, and this one, which are the neighbors of this point. And what might be the class of this test data? The class will be 1 because this is the most frequent neighbor classes. That's how it works. That was so easy, right? It is the end of the tutorial. I hope you liked it. To sum up, we have discussed the theoretical part of k nearest neighbors. We also compared its structure to other typical machine learning algorithms. Also, I highlighted all the steps of the algorithm as well as its distance matrices. In the end, I provided textual and visual example of the algorithm in order to be more understandable. In the next tutorial, we will discuss practical part of k nearest neighbor and build a project of wine quality evaluation. Make sure you subscribe in order not to miss it. See you in the next video.